All right, welcome back. I had some sort of snafu in that some of the videos I recorded earlier and decided to move them around. So that's why I say we're doing this next and we're doing that next because I am moving some of the videos around as I'm sort of going along here. Um, so next we're going to do the area under a curve. We're finally going to get to it. Okay, I promised it to you for 2 videos, I think. So area under a curve. So this is 9.2 video 4. No, actually, this will be 9.2 video 4. Not that any of you care, but if you're keeping track, I'm trying to make it easier so you can see where to look. Okay, so area under a curve. So we generally think of the area under a curve as like the integral from a to b, f of x dx. Let's change that to f lowercase. Okay, but now we're thinking about, remember, we're doing y and x as parametric equations. So what we would do is we would say we would switch this, and this goes from some ta to some tb, where x of ta equals a, x of tb equals b, and then it's going to be your y, and then instead of x dx, it's going to be x prime of, well, x prime dt. Okay, so let me put some room for variables in there, the t in there. Okay, so let's go ahead and do a problem. So let's find the area. I didn't realize that was red. I mean, I realized it was off, but find the area bounded by the curves x of t equals t minus 1 over t, y of t equals t plus 1 over t, and y equals 5 halves. Okay, whew. That's crazy, right? Okay, so the first thing is let's actually try to figure out what's going on here. Okay, so what I'm going to say is, I mean, we need to try to figure out what sort of curve this thing looks like in the xy plane, because it's weird, right? Okay, so what I do, and I'm only saying this because I had to look at it a bunch of times the first time I did it, is I take and I noticed something. I was like, you know what? I noticed x plus y equals 2t, and actually y minus x equals 2 over t. Okay, so let me write that as x, y plus x. Let's multiply those two things together. And again, no reason to do that other than I looked at it for a bunch and said, oh, that's what I should do. Okay, so when I do that, I get, look at that, y squared minus x squared equals 4. That's a hyperbola, isn't it? Y squared minus over 4 over x squared minus 4 equals 1. Okay, so let's draw that hyperbola. move it a little bit just to satisfy those of us that are OCD. Okay. All right, so that's, oh, it's even worse. Oh, I don't like those lines. Well, they'll just have to do. Okay, so now it's going to go up like so. We really only care about the top half because we're going to be bounding it by the line y equals 5 halves. So this line here, because this is a hyperbola that goes with a fundamental box of 2, okay, with size 2 in each direction. So this line here is y equals, let me write it on the other side. Okay, so what we're looking for is we're actually looking for this area here. Okay. All right, so we're gonna look, and what I'm gonna do, I'm just gonna take from here to here and multiply it by 2. Okay, so first things first, what position is this? Actually, let's not. Let's try from here to here. Let's see. So this point here, we need to find the times at which they intersect. Okay, so what we need to find y equals 5 halves, right? Okay, so let's do that. Let's find y equals 5 halves. Actually, probably never even needed to do all the graphing, but let's just do that. So 5 halves equals t plus 1 over t implies, let's take both sides, multiply everything through by t and 2. Okay, so we get 2t squared minus 5t plus 2 equals 0. We need to solve that. That's going to give us our 2 values of t. Okay, so the way that I do these is I do these by, if I can factor it, I try to. Okay, and I say, you know what? I need 2 numbers that multiply to 4, and in this case, add to 5. 4 and 1. So I'm going to write 5 as 4 plus 1. And then factor by grouping. Okay, so these are my 2t values. Okay, so now the integral I need to set up, okay, is just this integral up here, y times x prime. Okay, so it's going to be the integral from 1/2 to 2. Y is t plus 1 over t. X prime is what? 1 plus 1 over t squared. Dt. Okay, and that's not a crazy integral, I don't think. Oh, it is. It is, but you can actually do it not so bad. So I guess I will do this integral. So let's just multiply it out. It shouldn't be a hard integral. So t plus 1 over t plus 2 over t, so that's 2 over t minus 1 over t cubed dt. Ah, okay, now I know what's going on. That right here, this is not that area. That's why I was being stupid. That's not that. Okay? This is actually this area. Okay, so when we calculate what we've calculated here, let me copy this. What this is calculating, okay, is this area here. Okay, so what we really need to do is we need to take the area of this whole box minus that. So let's call this A. That's an easy integral to do. I'm not going to do it for you. Okay, but let's call it A1. Our total A, the one we're looking for, is going to be from 2 to 1/2, that's 1.5 times 5/2. Okay, because what's that? Minus our A1. Okay, because we are taking this full area is a box. Okay, that's the 1.5 times 5/2, and we're going to subtract off this. Okay? All right, I will see you all in the next video.